let's have some more fun with Tickle and Magic. So I'm going to load the first thing I want to show you, which is something called Vernier, and it loads it in. And what this is an alignment error checker between two layers, in this case metal 1 and N diffusion, and you can see that there's a little bit of an offset that changes as we come down. And so if we look right here, that there's no offset, right? We can even zoom in, all right? But that the M1 layer gets steadily and steadily higher as we go down from the center, and it goes lower as we go up. So what'll happen is when you make this feature on your mask and you align two things, if the alignment is perfect, yes, it'll be right across. You can see that this has the best or the minimized offset, so the error would be 0 or undetectable. Now what I've done is this offset is happening in 5 microns, so it's really only accurate, I'm sorry, 0.5 microns to 0.5 microns. And so if this one were misaligned and it was then these two would be perfectly flush, then I would count up and say, oh, that was a half micron error in the plus y direction. And if these two were flush, it would be 0.5, 1, 1.5, 2, 2.5 in the negative y direction. So again, only one of these can be aligned, right? It skips. And the accuracy is 0.5. Now you could draw a rectangle, and this one's fairly easy. You just copy it over at a various space. And here, though, you have to kind of misalign it according to an algorithm. And so one could draw this, right? But it's a real pain. So don't program it. And so we have the veneer width and length of 5 and 50, and accuracy of half a micron, and then we're setting the space, right? And then we go through how many fins we want to do. And first it'll draw metal 1, right, with the right offset, or oh, go back. All right, it draws metal 1, and those have the programmed offset, and then it draws the N diffusion layer, which is evenly spaced. Not going to explain everything about the code, but just understand that rather than having to draw that by hand, right, you can fix it, right? Now let's say you wanted to have an offset of a quarter, right? So now we're not going to be able to have as much range, but we will have more accuracy. And unfortunately, I need more programming because it flushed it here and not there, and I must not have done my algorithm correctly. However, it's not really, just trying to show you the power of it. And then maybe another fun one is I have a digital simulation of a differential equation for the quadratic integrate and fire neuron. And what it does is it plots it out on the wafer. So, so if I was making a circuit with a that was a quadratic integrating fire, I could put this image nearby, right? It's just fun. Um, so let's see if we can see it. Do it. Huh, that's right. There we go. You can see as it draws it for you, rather than placing it step by step. Well, so yeah, you can do any kind of automated artwork you want, or you could do a Lorenza tractor, but you could also, I mean, there's an algorithm for creating a QR code, right? And so you could put in the website where the data is stored for your project and create a QR code that prints out on the wafer, so that when you're looking under the microscope and you're wondering where does the data go, or what are the specifications of that particular thing, because that QR code could depend on the device, on the wafer, whatever you want, right? So that's just the power of automation. Tickle is used by a lot of EDA companies, and if they don't use it, they're using something very similar to it.